All right. So I was asked to do this talk, and I was given 15 minutes to talk about artificial intelligence, machine learning, and blockchain in context of some business. So let's do it, right? Yeah. All right. So I am Chris Slee. I'm one of the principals at AWH. I currently am the chief product officer. What that means is I don't actually do anything. I just sit in meetings and like come up with ideas and draw on whiteboards, and people are like, "Oh, that's smart. Let's do that." And then I go home at night with the imposter syndrome, and I'm like, "All right, let's do that." So in the course of the last 25 years of doing product development, so we do digital product development. So think of engineering, hardware, firmware, cloud connectivity, Bluetooth, um, the actual machining and sort of assembly of machines, right? As well as all the digital components that go into that. So there's a client that we have that is near and dear to my heart because I spend all my waking time with them right now. And so we're going to talk about them for a little bit rather than talk about AWH for a little bit. So this is a company called Include Health. I don't know if you've heard of them. They just got published last month in Forbes magazine. They're in this month in Forbes magazine. And what they do for a living is they started out a number of years ago with an industrial design student down at UC. He built the prototypes of this machine. This machine is a device that is targeted for accessibility for people to work out, right? So he went and sort of looked at a problem that he saw happen in a gym, which was a guy in a wheelchair, came in with all these pieces of equipment, was trying to use pieces and parts to interact with like Cybex machines and those kind of things. So he took on his design thesis to come up with a way to build a machine that could be accessible to anyone. So you don't have to have hands, you don't even have to have arms to use this machine. It takes care of everything for you. All right, cool. So that was his design thesis, and he graduated, and that thesis got picked up, and he won a ton of awards. So we went, well, let's make a business, right? As many young people do. And so over the last, it's just a startup that he's been working on for 12 years, right? So this amazing speed that we joke all the time about, everyone's like, oh, startup, how long have you been in business? 8 months, oh, okay. Well, he's been doing it for 12 years. He's been working on this thing, right? And now he's got traction and now it's working. But what he realized was the piece of hardware wasn't enough. So if you wanted to go work out and someone was going to buy this piece of hardware because it's not inexpensive, typically it's going to be a therapist, so someone doing physical therapy work, right? You have a shoulder injury, you have surgery on it, some healthcare system is going to have you go do physical therapy. Okay, cool. Having the machine that can set weights and count reps and those kind of things, that was good, but what they really wanted to do was be able to schedule patients on it, set up workouts, and go through that whole process of, hey, I need someone to do a chest press and then do a fly and then do a trap because they're working on their shoulders. Well, we need some sort of digital component to that, so we extended out into the cloud. Okay. So now we've got this cloud component on the web that physical therapists can use. They can schedule their patients into. It's at Mercy Health. It's at Ohio State. So the physical therapist can now schedule their stuff. The patient can come in, do the workout. We count all the reps. We count all the weights. So we can go back to a payer and say, yes, they actually did their physical therapy, right? But then we realized these machines, which are medical grade, wear out. So every 5 minutes, every machine that we have in the network calls home and gives us the status of their current state, right? So we know on these pulleys, for instance, how much range of motion has ever happened on that pulley. So when do we need to do maintenance? How many pulley pulls can happen before the sheathing on that cable is no longer medical grade and we have to go out and replace that component? All right? So that was a problem. We didn't know. So we would send well, they were engineers, but we would send maintenance people out to look at these machines and sort of determine how much breakage there needed to be and when they needed to do work. Very labor intensive, considering we have customers all over the country now, and we have to fly to these locations to walk into these offices to look at this machine and physically inspect it. Because a customer can't do that, we can't certify that. So we started collecting data. Like these machines, every 5 minutes, every machine in the system phones home, okay? So we get a lot of telemetry off the machines. How many times the solenoids that move the weight fire, how many times the encoders on the pulleys have actually moved. You know, all that information is there. So then we started tracing that back to our maintenance logs, and we came up with a data set that proved the truth. We use that as our truth marker, right? So when you do machine learning, how many of you guys machine learn? Okay. So the concept with machine learning is if you're going to teach a machine to do something, you give it a whole bunch of data, you cut it in half or split it, you give it the half of data that you know the answer to, you let it figure out sort of all of the relationships between all the different types of data that's in that data set, and then you give it a half of the data that it doesn't know the answer to, and then you see if it can tell you the correct answer that you already know, right? So we do predictive machine modeling based on that type of training. So we would train the models to understand when a machine would need maintenance, right? So we have all these machines out there. We started to do all that work. We use TensorFlow, which is, well, back in the day, when TensorFlow was new, it was sort of difficult to understand. It was hard to deal with. It's gotten a lot better since then, but this particular set of predictive maintenance is still running TensorFlow models because the model worked, right? So you take data, you train a model, you take the model, you go plug it in, and then you run your code around that model and you ask the model questions. You give the model data and the model will come back and go, don't need maintenance. Give the model more data, it'll come back and go, that machine needs maintenance next week, right? Sort of how it works. So the model still works, so we don't have to change the model. If we ever got more data or had to change the models, we would probably move it off of TensorFlow onto something else, right? So this is an example of using machine learning on a device that had no idea that there was an internet. So then we built the concept of the internet into the machine, and then we built the concept of, hey, you're alive and you have to tell us about yourself. Then we got to the point where we can look at a machine and predict when it's going to need maintenance based on its total usage, right? And what's always interesting about ML projects is the answer that the model will give you 70% of the time is non-intuitive. Like you think as humans, you'd be like, I could tell when you should go out and do that, right? It's when there's 10,000 pulley pulls or a solenoid has gone off 120,000 times. That's not always true. So the machine learning models actually give us better insight when to spend the money to fly somebody to a location and fix a machine before it's broken. Because you can't have a machine down because a therapist can't then do therapy, right? Cool. So in the process of building those machines, we built this little black box, and it's called the include sensor. Basically, it's a LiDAR and which is a laser rangefinder, right? It's got a gyro in it, and it's got an accelerometer and some Bluetooth stuff. And we can take that little device and put it on any piece of physical equipment. So, for instance, like this leg curl, or, yeah, it might be a curl. I can't tell. So we can put it on any piece of equipment, count reps, know the workout that the user is doing, right? But the iPad that we have here is actually the interface to the human, because obviously the little sensor is not a good interface for a person. But we have to track things like, okay, when's the battery dead in this thing, right? So now all these little sensors that we have out there in the field, wiring up all of these machines, are now phoning home all the time too, telling us information. So what you realize is once you start getting a lot of inflow of information, and some of it's important and some of it's not, ML is a great way to approach looking at, do I really understand what's important or not, right? We as humans make mistakes all the time, as evidenced by the previous slide deck. But while we let machine learning do it, it'll tell us things that we had no idea that there was a correlation to. And those are the fun types of projects that you run into when you're doing some kind of activity and you're like, this data shouldn't tell me the answer that it's telling me. And you start really digging into it and figuring out why. And the models will tell you things that you had never expected to know, right? So now we have these guys out in the field, right? And they're actually deployed in the military. So the Navy and the Air Force are currently using those things. So then we partnered up with Children's Hospital in Cincinnati, and they had some algorithms. Oh, here's a fun fact for you. The most injured person or the most injured athlete are teenage girls. The reason why teenage girls are the most injured athlete is because they don't jump and land in a non-injurious way. Meaning, when a girl jumps into the air, she lands differently than when a boy jumps into the air. Girl jumps into the air, she puts her knees together and lands like a triangle. So she gets an ACL injury, right? So Children's Hospital down in Cincinnati was like, why are so many girls getting ACL injuries? So they spawned off a whole bunch of grants, did a whole bunch of research over 9 or 10 years, and realized it's because they don't land the way boys land. It's a physical, how their bodies are built, right? It's just a difference. So then they did more research and realized you have, how many people ride a bike? All right, how many people have not ridden a bike in the last 3 years? That know how to ride a bike. Okay. Those people, I can guarantee you if you get on a bike, you can ride it. Right? We all know this. It's like, oh, it's like riding a bike, right? That's actually a cliche. The reason why is because you have a different type of memory for doing things like riding a bike. It's called procedural memory. Once you can do it, you will always be able to do it. Apparently playing the trumpet, same thing. Once you figure out how to do it, you'll always be able to do it. Whistling. No one can teach you how to whistle. You got to figure it out, right? So no one can actually teach you how to jump and land correctly, right? There's the joke that we use internally is you go to a golf pro and go, hey, what's wrong with my golf game? They'll give you 30 or 40 ways that you should be changing your swing, and then you actually address a ball and they go, now forget all that and just swing, right? You can't. You can't train somebody to do something procedurally, right? So what they did was they realized, okay, well, if there's this concept of procedural memory, how can we coach someone into doing something correctly without ruining it by trying to give them instruction, right? So what we did and what they did was they built, well, we didn't do it, what they did was they built I think it finally ultimately cost about $15 million. They built a room about the size of this room, and they have 60 cameras all around this room, and then they put the little dots on you, and then you would do exercises, and they would track your body, right? And then they would be able to tell you through this visual display if you're doing the thing correctly. So instead of going, hey, you need to go lower. Hey, keep your knees apart while you're doing a squat, right? What would happen is the screen would just give you a deformed block. And you had to do the exercise until the block wasn't deformed, right? Because that's procedural memory. Once you can do a squat without deforming the block in front of you, you're doing a squat correctly. You'll always remember how to do a squat correctly because it gets reinforced, right? Procedural memory. So what we ended up doing was, okay, well, they built this algorithm that can do a squat. Great. Can't do anything else. It could do a squat, right? But we can't sell a $15 million room to every customer. I mean, we're good, but that's not going to happen, right? So what we ended up doing was we worked with Microsoft. We got the Azure Connect cameras, the new cameras that can do body tracking. We did skeletal overlays, and then we're able to take all of that stuff that was in that room and bake it into this device. So there's actually a Connect camera in this device. So the Connect camera will watch you do that exercise, and then when you do the exercise correctly, you won't deform the display, right? So the military is adopting this, so we're actually deploying this in August at RightPad. So now we're looking at, okay, well, what's AR Kit going to do? Can I do similar things with just an iPad, right? But the ML that sits behind this is real-time coaching. They built a model that understands the relationships and the dynamics at different stages of an exercise, and then if you're doing it correctly. Now, I'm not 6'7", right? All right. But I'm also not 5'1". Well, how would the machine understand the differences between my knee position and my hip position, and my knee position and my foot position if I'm a different height, right? There's a scale problem there. And so our ML models also take that into account. So this is all in Azure ML. So the ML ops and some of those kind of things. So the last two that we talked about is all in Azure. It's all in the cloud. We take the data, we put it in Azure Machine Learning, we train the models, we export the models and then make them available. Like this one's actually available. We use Unity as our programming language for this, and a Connect camera. And then we take those models and put it actually in this device, and you can push that anywhere in the room, point it at somebody, tell them which exercise that they should be doing, and it'll give them the deformation information, right? It's things, there's a saying, you can't if then else your way into a self-driving car, right? You can't come up with hundreds and hundreds of thousands of lines of code and teach a car how to drive. It doesn't work. So you have to come up with a different way. So coming up with models that model things that we want, filtering data through it, that's how we train machines to do these kinds of things. And I know someone's really interested in the blockchain here. So we have done a couple of blockchain projects, but we actually have an initiative with Include Health. And there is a drive to push patient data into a healthcare blockchain. So concept of a blockchain, if people love blockchains, they hate when I say this, but there's a concept of a blockchain that you should only use a blockchain if there's two conditions that are true, right? Condition one is no one owns the data. Condition two is you don't trust each other. If that's the case, use a blockchain, right? So when I see organizations go, hey, I'm not going to pick on, I'm going to pick on Chase. When I see Chase going, yeah, we're going blockchain, it's like, why? You own the data, right? There's no reason for you to do that because it's your data. We struggle with clients like this client because they own the patient record. Your physician's EMR owns your patient record. You may think you do. You have HIPAA rights, right? But that EMR has a bunch of information in it that you'll never see. And they may trade it back and forth with other organizations, but really the ownership of your record is not yours. Your insurance company owns parts of your data that you will never see. The insurance company that you were at 3 insurance companies ago still has data on you that you don't have access to, right? You can't correct it, you can't adjust it because it doesn't exist as far as you're concerned. So when we work with customers on the blockchain front, we're really looking at it from that perspective, is there's a sovereignty to the ownership of data. If it's not yours, Include Health, then it belongs to somebody else. Who's it belong to? The patient. So at some point, we have to, as an organization, it's the pejorative, Include Health, has to participate in a healthcare blockchain, get permission to a healthcare blockchain, because eventually we're going to need access to patient data that isn't just things that we are accumulating because a therapist entered a first name and a last name and an email address, right? So this is actually one of our initiatives right now. We're looking at There's several competing healthcare blockchains out there, but we want to be on the forefront of participating in that with Include Health. So I have no idea how much time I took. 20 minutes. That's okay. All right. Are we going to do questions? Anyway, questions?